Right. Good evening, everybody. Right, I'm going to make the assumption you can all hear me. I'm going to bring up a little chat window. So if anything goes awry, like you can't hear me, then please do let me know. But yeah, I'm going to be 40-ish, hopefully, minutes with this presentation. It's going to be a bit of a demo in the middle, and I hope you're going to like it. So good evening, everyone. I know it's very different circumstances. I would have personally have loved to come down to the capital and present it in person, but obviously that's not possible. But it does mean, as the organisers say, we can reach a slightly broader audience, so not just London. We can get all the way out to Croydon and maybe even Stevenage with this. I join you this evening from the leafy suburbs of Wakefield in West Yorkshire. But wherever you're from, thank you for being here. It's very nice to have you along. So, on to the talk. I'm going to be talking about visualizing complex systems and talking about going beyond dashboards. Before I do that, I should probably do some introductions. So, hello, my name is Andy. Nice to be here. I've been at Skybet and Gaming for the last 6 years. I work as a lead platform engineer in the infrastructure platform engineering squad. For those of you that don't know Skybet and Gaming, we are the UK's most popular online bookmakers. We have a number of sports betting products as well as gaming products. My Twitter handle is on the screen at the bottom. We obviously have some form of Q&A system tonight, but if you are watching this afterwards, drop me a message on Twitter and I'll try and get back to you if you have any questions. And my pronouns are he and him. I spend most of my time working with Kubernetes, not exclusively, but the majority of my time. When I'm not doing that at work, I'm organising the Leeds DevOps meetup, so similar to the London one, but in Leeds. And I'm also on the organising team for DevOpsDays London, which, all being well, will be the 24th and 25th of September this year. Our CFP is still open, and that closes on the 25th of May, I believe. And hopefully, if all goes well, we will see you in London then. Let's see what happens with that. But I mentioned the DevOps conference for two reasons. Number one, because it's something I spend a lot of time doing. But this particular presentation starts at another DevOps conference with a talk from John Alspaugh, who John mentioned in the previous talk. I was lucky enough to be in San Francisco in 2017 when John gave a talk about keeping your systems running day after day. And he covered a load of stuff in this presentation. But one of the sort of key points of it was that we rely heavily on humans to keep our systems running, and that's not just documentation, that's the humans themselves. There are links on the screen here, but there's a section at the end of the deck which I will share, which has got all the links in, so you don't need to scribble anything down as you go along. And John elaborates on this theme of the humans being important by talking about above and below the line. And below the line are where our stacks live, that's where our repos live, our testing tools, our deployment tools, our monitoring, our logging, and even indeed our application stacks. And above the line is where the humans live. And he makes the point that even though we write things down in documentation and we draw diagrams, we still rely heavily on what's held in people's heads, the people that build the systems and run them, what is in their heads. You can prove this easily by getting your team to individually whiteboard out your stacks and your systems or your applications and your databases or whatever. You will probably find that not all of the descriptions match. Some stuff might be out of date, some stuff might be new to you. But we rely heavily on this cognitive load that we have in our heads, particularly as John points out, none of the stuff below the line actually exists. You can't actually go and physically inspect a message queue. At the end of the day, it's just electrons moving around circuit boards. So we rely heavily on our documentation, but even more on the information we have in our team's heads. And he also covers in that talk something called the Stellar Report, which is the output of a workshop about looking at how engineers cope with complexity. It's a fascinating read. I'd advise you to go and do it. The point which really ticked a box with me was number 4, supporting work through improved visualizations. And that's maybe because I'm a bit of a data nerd. I've done a lot of stuff with data analysis. I've got some qualifications in that. I've done some courses. And also, I'm a big fan of things like fractals, as well as like information is beautiful. This idea of getting meaning out of data, I really like that. So you might think that from the title of this talk, I might not have a very good opinion of dashboards, and that's not the case at all. I'm very much a fan of dashboards, particularly ones like this. They're succinct, to the point, they're very brief, and you get all the information you need off them. But for me, dashboards are a little bit like jokes. If you have to explain it, it's probably not a good one. I'm just reading the chat here. Have we got some problems? No, we haven't. Okay, I'll carry on.
No, good,
okay, cool. With dashboards, even if you like go on like Grafana's like community dashboards or the whole plethora of monitoring tools available, I'm seeing an increasing number of dashboards becoming live data documents with every metric you could possibly conceive for a technology on that dashboard. And to me, that's kind of losing the point. And sometimes these lines, these graphs can be confusing. Are spikes good? Are they bad? Are groups of lines compared to other groups of lines important? But the main thing for me that I can't see from a dashboard is I can't see the structure of a system. I can't see the components. I can't see the dependencies and the interactions between them. And that's really where I think with these complex systems, we can start visualizing the structures and these interactions. And that's one of the reasons why I like working with Kubernetes, because there is a structure. Admittedly, the application within it has its own structure, but you've got some constructs and you've got some structure to the workloads which you can build your systems from. To me, that's really useful. So could we visualize Kubernetes systems? Well, yes, we can, but if that's your tool for visualizing your cluster, that's going to be a little bit hard work. It's not impossible. And for those of you that work with Kubernetes and don't know, and this may be the main takeaway from this talk tonight, is -A is a replacement for -- all namespaces. If you don't know, I think that might be really useful for you if you work with Kubernetes. So how could we look at the structure of the relationships between objects and possibly their interactions and the different types of objects that exist in a complex system? Well, maybe we could use graphs, and I don't mean pie charts. I don't mean histograms. I mean these kind of graphs. So this is a graph made up of nodes and edges. And probably about 10 years ago, this was an incredibly popular way to show off on social media how many friends you had. You would typically download the data out of your Facebook friends, and you would use some sort of tool to visualize them, and you could see the different groups of friends you had, the relationships between the people in those different groups, and we could even size them by how long you'd known them. And this was great fun to tweet these out with the hashtag of data science, mainly to show off how popular we were, but also really to annoy people who were doing proper data science. But graphs are really good, they're really useful, and they're really simple. So with a graph, we have two constructs. We have a node, so that's a type of thing, and we have an edge, which is a relationship between one or more types of thing. So in this example, we could have two nodes, so we could have two people. They have different attributes, they have different heights, obviously different names, probably different favorite colors, etc. And the relationship between them could be one node likes another node. And this can be directed as well. It doesn't have to be bidirectional. And equally, we could put a weight on this relationship as well. So we can say that somebody really likes somebody, or maybe likes them 10 or 20 or 30, whatever our scale is. And in some systems, we can even put attributes, properties on these relationships as well. But these nodes and these edges don't have to be people. They could be a class inside your application code or an instance of an object. It could be a device. It could be a port or a socket. So it could be a physical device as well. And it could be a row or a record in some data store somewhere, or it could be like an API endpoint. And the edges, they could be the dependencies between different objects. They could be a usage, they could indicate volume, they could indicate flow, they could indicate some sort of link. And there's a whole science built around analyzing these graphs called social network analysis and also called graph theory, two very similar approaches to analyzing these graphs. But one thing these could be is they could be Kubernetes objects and the relationships between them. So could we visualize them using a graph database? Well, actually you can. And I'll go through one of these examples in a moment, but we've got, on the left, we've got something called KViz, which is a little visualization tool in your browser. You might have seen WeaveScope before. This is a way of drilling down into the different groups of objects within a Kubernetes cluster and seeing the relationships between them. And then there's the, well, now defunct Kubernetes plugin for Cockpit, which did a similar job to KViz. So I spent some time having a look at how we can visualize these clusters in a little bit more detail. So I'm going to do a quick demo of what I've done. It does contain a lot of moving imagery. Some of it's quite fast moving, some of it flickers and flashes. So if you are sensitive to moving images, I don't want anyone to be uncomfortable watching this presentation. So you might want to skip the next 15, 18 minutes or so. I realize this isn't a Kubernetes meetup either, and I'm going to show Kubernetes, so it might be worth a little bit of a crash course. So within Kubernetes object hierarchy, at the top of the tree, we have the namespace. So this is how we group different objects together. So that might be owned by a team or by an application. So we might group things together. And at the bottom of the tree, we've got something called a pod, and that's where your containers live and where they run. And they run on something called a node, a Kubernetes node. So we've got namespaces, we've got the construct that holds the containers, and then they actually physically run on a Kubernetes node, which could be a VM or a piece of physical kit. And then in the middle, we've got all sorts of different workload objects which help manage those pods. Okay, so let's flip to the demo. Now, this is a video. I've done this for two reasons. One, there is a lot less chance of demo fail. And number two, I know how long I'm going to be. So let's have a look at this. So this is KViz. This is one of the tools I mentioned before, and it's an open source little tool. And what it will do, you point it at your Kubernetes cluster, and it will render it using something called a D3 force layout graph. And here it is. This is my little development cluster on my machine, and I can drag it around and do some exploratory stuff. If we want to go a bit heavier than that, we can use an enterprise level graph database like Neo4j. And in this article, the author is using an extension to talk to the Kubernetes API endpoint and pull back all those objects I was talking about before. And then built into Neo4j, we've got a little visualization tool so we can start seeing the objects within it. And this is Neo4j. As I say, it's a graph database that's commercially available, but there's a community release. I'm running it here through Docker, so expose some ports, map to a folder on my hard drive, so the data's transient, and also some additional options on there so that I can enable some extensions. So we just start it up like that. This is some Go code I wrote. I didn't want to use the raw Kubernetes API, so I wrote some Go code. In fact, I wrote a lot of Go code. And basically, I loop through the Kubernetes object hierarchy in a cluster, pull all the objects back, so all those namespaces, all those pods, and all those Kubernetes nodes and the workload objects, and all the relationships between them. And that is sent over to Neo4j, so we can start having a look and doing some analysis of the cluster there. So let's flip over to Neo4j and have a look at what's moved in there. I've run this already because it's not particularly exciting to watch. And I can see I've got 5,500 nodes off this test cluster I analyzed and over 7,000 relationships. Now, Neo4j's got a querying language called Cypher, which is a bit like SQL if you've used that. And I can do queries on the nodes inside Neo4j, and I get sort of information back about it. I can do aggregate functions as well, so I can do sums and groups, but I can also use the built-in object browser. So in this case, what I'm going to do is pull back something called a deployment called Trickster and all the things it's connected to. So here I am my deployment, and I've got some pods there. There's the pods where the containers run. You can see all the properties associated with that. And there's something called a replica set, and this deployment is a workload object. If I expand that out, I can start doing some exploratory analysis. So I can sort of lay this out as I want. And if I start looking at the pods in more detail, I can see the Kubernetes nodes where they run. I can also see something now called a service and a namespace. So this is a network connection to the pods, and the namespace is obviously the object which holds the collection of all these other objects. So you can see straight away I'm starting to see bits of the system just by quite a simple query. Now, this is an interesting one because what I'm doing here is I'm supplying Neo4j a particular object, pod, and saying, find me all the objects between it and the namespace. And Neo4j will just pull back all the objects. It doesn't care what type those objects are. So in this case, it's something called a deployment, but equally, it could be a stateful set or a daemon set. And again, I can start exploring this and expanding out. So this is pretty much what I had before, but I can, of course, keep going. And expand out these objects time and time again until I've got pretty much all the objects displayed. It's quite a laborious process. You can do this with the Cypher query language. And this is fine until we reach a couple of thousand objects. And then your browser will start to struggle to render it. So we probably need something a little bit more lightweight if we want to look at a whole cluster. So the next example I'm going to show, after we finished expanding around this, is a library which will use JavaScript to render it in your browser. So this is D3. This is primarily Mike Bostock's project, but there's a load of other contributors, this open source tool. And D3 has a whole bunch of layouts which we can use to visualize objects. Again, that struggles at a certain point. So this is a version which uses WebGL, so it uses the sort of like 3D rendering engine. And this example would talk to Neo4j, and I worked out really quickly that I could take this example, change the connection string to my local Neo4j, tweak the cipher a bit, and in about a couple of minutes, I discovered that you can get some quite spectacular results. So hopefully this will be nice and quick on your end. But you can see we get all our 5,500 objects and relationships rendered out as a 3D object, and we can click on it and scroll it around and twist it and zoom in and out, and that's kind of useful. I stuck it on the big monitor we have in our office at work because I was doing this over lunchtime, and when my workmates got back from lunch, mixed opinions. Some people thought it was one of the coolest things they'd ever seen, doing Minority Report motions. Other people thought it was just a big hairball of noise. Now that opinion is shared by a few people. This is Martin Stravinsky. He has, in his opinion, a better way of rendering out these complex networks using something called a hive plot, and he's very much against the hairball. So much so he pleads with us there. Now, the thing with these graph layouts is, as he points out here, if you rotate the same layout, you can imply different meaning from it. And if you use a different way to lay out that graph, you can impair or you can imply all sorts of meanings from the same data. So I thought this isn't really going to be what I needed. What I might use is a tool I used many years ago when I was doing my data analysis courses. And there's a tool called Gaffy, which allows you to analyze networks of people or computers and find out the significance of people in the network using the whole science of social network analysis and also graph theory. Now, we can pull data in to Gaffy using the streaming interface I've just enabled there. It will import CSVs and all sorts of stuff. But with Neo4j, there's an extension built in which allows me to move the data or copy the data from Neo4j and send it over to Gaffy. So what I'm doing is I'm going to run this piece of code which pulls back all the properties for all the nodes. And that's going to start transferring it over to Gaffy. So it's a little bit of a slow process. But if we go over to Gaffy and start seeing what's happening, in the top right of the screen, there's a counter showing the number of nodes and edges going up. Through the power of video editing, we're going to skip forward to the 5,000 mark, and you'll see all the dots and relationships appearing in the middle of the overview area in the middle. So we're just a few short. We wanted 5, 5, 6, 7. We're a couple of bits of data short there. So let's go back and just pull back all the things that aren't connected to the main component in the network, because that's what we moved across. So a little bit of a tweak to the cipher. Same thing, we're moving all the objects across. So we've got 5, 5, 6, 7 nodes, 7, 2, 3, 4 relationships. Let's go back to Gaffy. There we go, 5, 5, 6, 7, 7, 2, 3, 4. So let's look at it in something called the overview tab, sorry, the data laboratory now. And this is a bit like a built-in Excel spreadsheet of all the data. So you can see all the different types of Kubernetes objects there, and the different columns have different values based on that type of object in the middle. So we can see all of the 5,500 objects there, and we can do the same with the relationships as well. But let's use the overview to start doing some visualization on this. So let's color the nodes to start with. So let's apply a palette. I'll just move this over to the right so you can see it. And now we can see all the different objects in Kubernetes, the number of them, and we have applied those colors to the objects in the big block in the middle. Well, the big block in the middle is no use, so let's use a layout to lay out all of those nodes. And we can see something very similar to the 3D image we saw. This is positioning the elements based on their relationships and kind of gravitational forces that are calculated between those objects. So let's zoom in and see what we've actually got. Let's try and see if we can see this Kubernetes structure rather than the pretty picture. So that's something called a deployment, which is replica sets and a namespace, which we talked about the namespace. That replica set points to a pod, which is where our containers run, and then we've got a service and back to the namespace. So we've got kind of like a triangular layout there. And that particular pod runs on a Kubernetes node somewhere, which is right in the middle of the hairball. Let's see if we can find it. No, I don't think it was that one. It illustrates the point. So if we pick a node, sorry, pick a pod, we can see it runs on a node. And if we look at the node, we can see all the pods that run on that node. So this is great, but it is very hairbally. What do we do about it? Well, let's just have a look at some other bits of the cluster first before we start analyzing that. So up at this top end, we've got a namespace with a load of workloads that aren't really doing anything. This kind of like fluffy head of the cluster, so to speak. So I could use these statistical tools, which I would have used with social network analysis, to find out properties about all the objects in the graph. But really what I found useful is if you start filtering this graph and only showing certain types of object. So in this case, I'm going to look at it rather than as the collection of all the objects. I'm going to take the Kubernetes nodes out where the pods run. So I'm looking at the workloads individually here. I'm looking at these namespaces and all the workload objects grouped around them. And suddenly we split off into different little objects, and if I run a slightly different layout, we can start seeing these namespaces and all the workloads around them. So we've got some idea of the structure of the applications that are running on our cluster. We can turn some labels on and we can go look at the names of the objects. Obviously, this is off one of our test clusters, but I've mangled all the names for obvious reasons. So we could start investigating those objects there. We can go into the data laboratory and find them, or we can even go back to Neo4j and start analyzing them there. Again, if we sort of look around this namespace, that's very different to all the others. We'll look at that in some more.
What's happened there? Hello, Andy. Are you still there?
Replica sets. So let's look at it from a slightly different perspective now. We've looked at it from the workload. Let's look at it from the perspective of execution, from compute. So here we've got all the pods and nodes. And if we separate those out, we can see these little islands are just the nodes where the pods run, and we can see all the pods grouped around them. So we could probably find out some more meaning from this by changing the appearance. So let's color these by the state of the pod. If I apply that, and what I can start to see here is not just that things are running or things have succeeded, but I can also start to see that there's some failures. And maybe that means that node's got a problem. Maybe it doesn't. But again, I can go and look in the Neo4j, or I can go and look in the data laboratory. And I can also size these by any of the properties I've got. I'm going to choose the amount of CPU that each of these pods has requested. And if I size them and zoom out, first of all, I can see that the Kubernetes scheduler has done a very good job of distributing the workload around my nodes, well, in Kubernetes. But also I can see that rather large one there, and I can go and find out what it is. I can go and find out information about it, and I can have a conversation with maybe the team that put that pod onto the cluster. So already we're starting to understand a lot more about the workloads that run on our clusters. This is a different piece of Go. This uses something called a shared informer, for those of you that have used the Kubernetes client. And what this does is this pulls back all the objects and writes each one out in a log of when it was created, when it was deleted, and when it was updated. So I've basically got a timestamp log of each action, the type of object, and some properties. And in this case, I've also pulled a lot of information out of the metrics for CPU usage and also for memory usage, so I can kind of have the progress of how things are progressing. Then I noticed a pattern in the data. There seem to be these relationships being created and deleted, and this pattern repeated throughout the data, and it was using something called the toggle namespace. So we'll go and have a look at that when we start pulling this data into Gaffy and doing some analysis on it. So this log file, as it stands at the minute, isn't a lot of use. It's not something that Gaffy can read. So another piece of Go, which will create a graph exchange file, which is something that Gaffy can read. And what that does is that loops through that log file and it builds up a large XML document of all the objects and all the relationships between them. So this is a resulting XML file, and we can see each of the nodes being the objects. And if you look closely, you'll be able to see some timestamps there indicating when objects were created and when they were deleted or updated. So let's pull that into Gaffy and see what we can find. So we pull that data in, and it appears as a rather unattractive large black box. So let's color it as we did before. We've not got quite so many metrics on this, but we now got all the data pulled in, which looks very much like it did before, but we've got this extra field of interval now, which, as I say, is when the object is created or removed from the cluster. So if we run the layout on our set of data that we had before, so let's lay it out very similar to we had before. It looks a little bit different because we pulled it in a different way, but it's essentially the same objects. What the more observant of you will notice is there's a big enable timeline button at the bottom. Now, if we do this, what it allows us to do is filter the cluster based on when the objects were there. In this example, it's pretty static, but if I size the objects by the CPU metrics, CPU usage, and I hit play, that playback head moves, and you can see the objects resizing based on how much CPU usage they're using in the middle, which is kind of useful because we can look at the cluster at any point during that particular time window. Let's go and have a look at the toggle namespace, which was causing me some grief before. So I can select it in the overview from the data laboratory, and it's there on the left. If I move the little time window along and I scroll along the timeline, you'll see a green line appearing and disappearing between something called the toggle DB service, that green node there, and one of the pods to its right, which is blue in this case. So the green line is there. And as I move the playback head along, you will see that that particular line appears and disappears. So I can go and look at the cluster and find out what particular, what the problem is with that particular namespace. Let's do something a little bit more visual. So this is a little bit kind of hopefully crowd pleasing. There are some applications to this, which you'll see later. But this is taking all the objects, putting them in a big circle, and then changing the time window down to the beginning, and basically applying the layout to that. And what we're going to do is we're going to see what happens as this cluster, which is a different one, scales up on a morning. This development team scheduling their workloads. So all the workloads fly in from the edge of the cluster and join the relevant namespace and Kubernetes nodes it needs. Let's look at it though, as we did originally from the workload perspective. So let's remove all the Kubernetes nodes from this diagram. And if we do this, we end up with the namespace objects, as we've seen before, dotted around. And if I hit play, I can see which namespace all the pods from the outside are going to as they're created, which is kind of useful. It's a little bit more useful for the final example if we look at it by compute. So if I arrange it in a circle, I select a small part of the timeline and choose pods and Kubernetes nodes, and then run the layout on that. What you'll see is the workloads, so the Kubernetes nodes, and if we hit play, we'll see all the pods joining the nodes where they execute. I'm just going to point something out here. There's a little area here, and you're going to see a node being scaled up. So a new node's going to be created. Here it comes, and you'll see all the workloads, all the new workloads going to that. So there is some useful applications in this, particularly for working out where the state of the cluster is on the timeline. And it doesn't have to be this layout. There are loads of layouts in here. This is a hierarchical one. I'm going to organize things by type and namespace so we can see all the different objects grouped together. If I size them by, let's say, by the CPU request for each of these pods and lay it out again, I quite like it on black. You can see where the noisy namespaces are and have we got namespaces which are got more requests than others. And there's something called the preview window we've not used before, but this allows us to render a nice vector which we can pull into our desktop publishing applications and print off and give to our family as gifts, or more practically to our work colleagues. This is something completely different. This is D3. This is a JavaScript framework that is doing something called a parallel coordinates graph, and each line across there is a pod extracted from Neo4j, and they're plotted across the axes for the various dimensions of data we've got. But it allows us to see where the common ones are and where they aren't. So hopefully that was viewable for you all, and hopefully the internet connection held up and you got the full effect of that demo. So what have we learned from doing this? Because yes, we made some very interesting looking animations from it. But as you can probably guess, there are some practical applications, which is the reason we did it. First thing to say is our live clusters are really boring. They're nowhere near as interesting as our test clusters. Really reassuring, because that means that our development teams and indeed these platforms are experimenting and trying things out, and that culture of learning and that culture of experimentation is something I'm really pleased we've got at Sky Betting and Gaming. I would be very upset if everything was dull and we weren't finding anomalies and we weren't finding interesting things, and then being able to have conversations with people about it. So this was one of the very first renders. I don't think I've got all the objects in at this point, but you can see this is our Neo4j, and you can see there are these yellow daisies that look like, and what these are these the deployment workload objects, and the replica sets are the little yellow ones connected to it. And normally there are 10 replica sets in a deployment in its history. Somebody had turned the dial up to 11, which is fine. We can have conversations with team and we can learn from that. But we learn from that, and we learn what people are using the cluster for. So that's really cool. This was an interesting one. I mentioned before with Neo4j, the power of the graph database and the querying language there is the fact we can ask vague things and we can get information back. So in this case, I am asking for all the services that aren't connected to anything else in their namespaces. So I can see immediately that we've got a bunch of unused objects here. And that's really useful because, again, we can find out what they are and work out why they're not being utilized. Maybe something's failing on the cluster, or maybe this is just a legacy workload which needs to be removed. If we start sizing and comparing from these different ideas of workload or by compute or just in the overview here, we can see in this case where noisy neighbors stand relative to one another. So we can see, particularly on the memory request, there's a little cluster there, and that allows us to go and look at that cluster of high memory requesting pods and work out if they're related and if there's a pattern there, if there's something going on. We have to be very careful though, because we must double check our data. Any data scientist will tell us we need to check our data and make sure we have our facts right, because sometimes the Kubernetes API lies to us. In this particular example, we have 2 pods which apparently requested 1 million terabytes of RAM. I only wish our clusters had 1 million terabytes of RAM. They don't. Instead, it was 1.2 gigabytes. But the Kubernetes API was reporting the wrong number back to us, which was an interesting discussion. I spoke about this idea of this kind of like hairball of the cluster and the this overloaded workspace is what we thought it was. So I did some analysis and we split it into 2 to work out what was going on. And the results were really surprising. So from the hairball, if we filtered out all the stuff that wasn't used, we took away all the unused nodes in there, we could see that it was actually a lot simpler. The workloads, there's still a lot of complexity there. There's still this mishmash of interconnected nodes there, which is still not really easy to get any meaning out of. But when we looked at our workload, which was really big, and we filtered everything out which wasn't being used, we realized that this was actually quite a well-managed namespace. And we spoke to the team about it, and they scale things up and they scale things down when they need them. It's very, very, very well managed. But of course, our initial reaction to it was that this is, chaos. What's going on here? But actually, it was far from that. And we've been able to find things which we wouldn't have thought to look for without seeing them in the visual format, if that makes sense. So this is the cluster with all of the unused objects removed, sized by age. And what we realized was if we filtered that and just looked at something called the replica sets, which are groups of pods, anything that's been around a while, so a larger shape, indicated that potentially the pods connected to it had also been there a while. And that could indicate that we've got some old workloads running, possibly with outdated code, maybe some bugs, possibly some vulnerabilities in there. And again, we can go and talk to the teams about that. If we look at the cluster by the compute, so we just look at the nodes of the pods, and look at restarts, we can see one particular node has 2 pods which have restarted quite a lot. Now, that could be a problem with that node. We probably wouldn't have picked up on that without doing this. If we look at it from compute, but we size it by the amount of requests and look at the state of the pods that are running, we can see we've got ones that are running, we can see we've got succeeded ones, but we can see little clusters of failed pods. Again, that might indicate that that node has got a problem. It could be the workloads, but it might be the node, but we can go and drill down and go and find out what's going on there. You'll also notice that we've got some little gray dots there. These are pending pods. So these are workloads that haven't been scheduled yet. Now, this highlighted a real problem with this approach as well, because we could see that there were pods there and they hadn't been scheduled. Maybe there wasn't enough resource. Maybe there was some scheduling problem with them, with some rules around them. But it was a point in time when we took the data. So we don't know what happened in 2 minutes time, 3 minutes, 4 minutes, 5 minutes, or equally 2 or 3 minutes or 4 minutes before that. So we didn't really have a lot of context to what that was as to if that was a problem or not. If we look at things by namespace, so we look at things by the workload and color them by status and size them by CPU requests, we can see the noisy workloads, but we can also see the workloads that have got some problems. There's one at the bottom there, which has a lot of failed pods. Maybe that workload has a problem. Maybe there's something wrong with the configuration there. Again, we can look at it. But for all this great way of seeing things and determining a way that we might have to analyze something, we can still jump to conclusions. We can still use all our cognitive biases to go, that's a problem. So in this particular one, there's a node at the bottom of the screen, loads of workloads around it, not connected to anything else. What's going on there? That's a problem. And the TLDR was, I should pay attention at stand up when I know people are load testing particular nodes in the cluster. Whoops. Okay. So there's some of the things we've learned. What are we going to do next? What are we going to expand this with? Well, there's still a load of Kubernetes objects I haven't looked at. I haven't looked at anything to do with storage. I haven't looked at anything to do with how things are configured or the permissions model within Kubernetes. Neither have I pulled in the tons of metric data we have out of our metrics platforms, which we could pull in and use in the visualization. But the really obvious one, which maybe some people are screaming at me now, is what about networks? Well, of course, we realize that, and we're not the first people to realize that. This little tweet here is from Jack, who works at Monzo. A mutual friend put us in touch. We exchanged a little conversation, and he explained he had the network and the telemetry data, and he basically rendered that in Gaffy. So that's actually done in Gaffy as well. I'm not sure what they've done with that since, but I know they're doing some work on visualizing clusters as well. But inside the cluster with all these network policies, so what can talk to what. We've got the service mesh, we've got also the rules, we've got the traffic data, all the telemetry, and we've got services as well, which tell us what the endpoints are within the cluster. And this is really, really useful. And one of the best examples I've seen of this, I mentioned earlier that I'd done some courses in social network analysis and in graph theory, so this way of analyzing these clusters and understanding the significance of a position within a network, the significance of how things are connected, whether things are in a community or a cluster within the cluster. And Nicky Watt, who's CTO at OpenCreode, gave this talk at GoTo Berlin, where they used all the telemetry data from the network connections between a microservices API and analyzed it and worked out which were the chatty ones, which were the ones that were tightly coupled, which ones weren't. And they used this graph theory to work that out and re-architected their APIs around it. Fascinating talk. Go and watch it. Before you all run out and download Gaffy, some caveats. It's not had a release in 3 years. It's been around 10 years, but its futures in its current form is a little bit in doubt. They are rebuilding the graphical interface because the WebGL or the OpenGL library it uses is deprecated. It's a lot of fun to use. It can be a little quirky. But if you are interested in using it and trying it out, I have tons of links in the resource section at the end of the file, which I'll, of course, share with you. What we might be doing is we saw the parallel coordinate graph, the one on the right there, in the demo. We might start doing more things in D3. The D3 has got a plethora of different libraries for doing different visualizations. There's the observable HQ in the middle, which is kind of like a notebook format, but for D3 visualizations. And I really like the idea of the notebook format, because at the minute, our visualizations are kind of locked away where we can see them within the infrastructure platform engineering squad. They're not being shared. And the idea of putting things in a place where we can share these visualizations and put notes and explain things, I think is really, really powerful. Because at the end of the day, you know, we're all doing the DevOps thing. We're trying to get rid of that wall between Dev and Ops, and we're trying to collaborate, and we're trying to take information that we have and make knowledge out of it rather than just opinion. And particularly within the team I work with, we've split our squad into a couple of different sub-teams. So I work in kind of like a DevRel team now. So this information has been invaluable. And if you read Matthew and Manuel's book here, I really like it for two reasons. Number one, Sky Betting and Gaming are in it. But the other one is it's just a brilliant book. And in that, they talk about 4 essential types of teams. We're certainly an enabling team. And the kind of knowledge we have got from doing this analysis and this investigation means that the conversations we are having with the people using our clusters are so much better informed, so much more common knowledge about what we're talking about. And it's really empowering us to actually do our job better. And there's almost a point that we don't need to share the visualizations because we're having the right conversations. So let's wrap up. In summary, have I solved this problem from the Stellar report? Well, I mentioned we're not really sharing the visualizations, but they're acting as an input for us to talk about things. We probably are going to do some form of visualization and productization of this research. But no, it's not a tool that we've shared with anyone yet. That's still to be decided on. I think what we're going to do is we're going to look at this point in time analysis, this timeline enabled view. Probably render these graph exchange files throughout the day so that we can pull them into a tool like Gaffy and then literally look at point in time what a cluster looked like. And I think that's going to be really valuable, say, for example, in an incident where we can look at what the cluster looked like before the problem, during the problem, and after the problem. I can't think of any other way of doing that other than with a tool like this. And I think we're almost there to having that. Even without this tool, the point in time, the narrowing it down, the fact we've got the data in a graph database allows us to find things out we've not been able to do before. We've not been able to ask questions about it before. Really, really powerful to have an insight which we've not had before. Just on terms of complex systems and what I think I've learned from them. People have different definitions of complex systems. I get that. I'm very much about the hairball. I think if you've got a hairball, you've got a complex system, and I don't think that really helps you understand it. But if you look at it from a perspective, if you can filter out data, and particularly in our case, we've looked at workload, we've looked at compute. If we could pull in more stuff and start looking at connectivity and security, that would be really powerful to compare these different perspectives to understand what's going on. So just one more thing. We have a resources section in this deck, which I will share with you. There are links to every talk, every book, every web page I've shown or read in the process of making all this research. So things from D3 through to Gaffy tutorials, the actual Go code as well to extract the data off the cluster, courses, books, as I say, and indeed the link to Nikki's talk as well. They're all there. They're all for you. I've gone slightly over. I hope connectivity-wise, you managed to see the demo properly. If not, there are some other recordings of this which I can share as well. But thank you very much for listening to me this evening, and let's have some questions.
Good stuff, Andy. Thank you very much. I don't know about for anybody else, but for me, we had a little pause where we lost you for a few seconds, but then the video caught up. So I think it all worked out really nicely.
Okay.
Unlike my virtual background, which is now glitching because it's getting dark. But there we go. Yes, excellent, interesting stuff there. So we did get a few questions come in. So firstly from Hamad. Hi, Hamad. So you mentioned Gaffy and D3, and this could be a one-word answer involving 2 letters. But are there any other good tools for data visualization that you know of?
Depends what you want to visualize. Obviously D3, you have to kind of do it yourself. The reason I chose Gaffy was because it had all this exploratory facility in it. I could go and hide things, show things, look at the data, and that was all there. Other tools, there are a few kicking around. I mean, I've not played with things like Tableau or Power BI. Maybe they've got some way of doing it. The thing I'm going to look at next, though, is probably look at these notebook format document-based things, so I can share them. So probably something like Jupyter or even Shiny if I decide to use R.
Okay, cool. Next question from our friend anonymous attendee. Do you have one large production cluster or many production clusters for different business lines or workloads? And do you get proactive monitoring and alerts from those tools?
So yes, we have a number of different clusters based on environments and segmentation down to business security based on the elasticity of what we need. So we do have a couple of different clusters. We primarily monitor it with a mixture of Prometheus, Alert Manager, and PagerDuty. I don't think I'm giving away any secrets there. So at the minute, these tools aren't feeding into that, but there's no reason why they might not in the future.
Excellent. Okay. Final question I'll take here. Sorry, this is quite a long one, so I'm going to try and summarize it. So the visualizations look really powerful and useful, but as you say, you haven't got them as far as the dashboard that doesn't need to be explained. Do you think you'll be able to put some of those visualizations on dashboards? And any ideas on how?
Well, one of the original ideas when I was kicking this around was my colleague wanted the big cluster visualization on the screen. And what we realized was, as we were doing it, was like, is that really that valuable? Having this whole kind of like hairball there, are you actually going to get any meaning out of it? What I think I'm going to look at, instead of looking at the whole thing, is produce something a bit like the KViz tool that can show a team just their stuff. I think that might be really useful. So they've got a visual representation of it as well. So I think that might be really useful. I know if anybody's seen any of the demos by Auto Trader, based up in Manchester, they show their deployment management dashboard, and that's got something very similar to KViz. It might be KViz, I don't know, built into it. I think that kind of thing is really useful, where you can see your workloads that your team own, and then you can go and see what it looks like, as well as get like the logs, etc. from it, metrics.
Excellent. Good. Okay. I think we're done then. So panelists, if you want to just open your mics up and we'll give you a bit of a round of applause. You'll have to take it from us 5, but there we go. Thank you. Yes, lots of nice comments coming in the chat. So thank you to all of you for participating there. So stay safe, stay alert, and we'll see you next time. Cheers, everyone. Bye-bye.
Cheers, everyone. Bye.